let's start taking a look at 3.3 here. And the difference today compared to any other of the notes that we've taken in Chapter 3 so far is this idea of solving equations with variables on both sides. Okay? Now when I talk about this, just let me show you an example. If I ask you guys, look at this equation right here, 3n plus 7 equals 28. You guys would easily tell me that your first step in solving this would be what? Minus a 7 and then divide by what? Divide by 3, okay? Notice, if I put a line right here, how many of those sides, or how many of the two sides, I should say, have a variable on it? Is there a variable on the left side? What is my variable on the left side?
3n.
Is there a variable on the right side?
No.
So this is a case where there's just a variable on one side. That's all we've looked at so far. So today what's going to be different is we're going to start looking at stuff like this. What if I have 3 times some number plus 7 is equal to, I don't know, maybe some number minus 14 like that. Now, if I would draw my line right here and ask the same question, how many sides do I have a variable on now? 2 of them. I've got them on the left and I've got them on the right. And that's what's going to be unique today for us to look at, try and solve problems with today, okay? A couple practical examples at the end of this, and I think you'll do just fine with it, but there's going to be some unique cases today, and you'll want to make darn sure you take good notes. So anything I put a nice star by today, make sure you understand why we're putting a star by it, so you understand the difference between problems that are going to have a solution and problems that may not necessarily have a solution. Okay? So guys, real quickly, solving equations with variables on both sides. Our goal is to solve equations with variables on both sides. All right? And we understand that what we're talking about is basically having a variable on the left side equal sign and a variable on the right side equal sign now, and how to work that. Okay? All right. So just like all the other notes, haven't we had kind of rules to figure out how to solve all this stuff? Okay. In the last section, what was our first rule? What was our first rule, you remember? Okay, in this new section right here, what's the first rule again? Distributive possible. So we're looking to get rid of any parentheses. Great. Okay. Second rule. What's it say?
Combine like terms on either side.
We've done that before, haven't we?
Yeah.
Okay. Why do you think I put step 3 in red?
Get variables on the same side.
Probably the part that's going to be maybe a little new for us too, right? Okay. It's important, yes, I agree. But it's also what's pretty much new for us today, all right? So you might want to just go ahead. I know yours isn't in red, but you might want to go ahead and just write down that step 3 is new for us, okay? Finally, step 4 and step 5, don't those look familiar? Okay, so as we're working our way through this today, where are you going to refer all the time? The rules. Follow that step by step as you're working through these problems, and I think we'll be okay. So let's go ahead, and let's just jump right into example 1, so we know how to apply this to a real situation here in a second. So the problem I'm looking at, I'm going to zoom in a bit, I think, so I have room to work. Whoa. Mr. Fleschner, if you're in here, I can really read that really well. I thank you very much.
I'm sure you can read it.
Here's the dealio, okay? I don't have the rules all the way up there, but guys, if you would take a look at your top rule in solving this. Rule number 1 says to distribute, doesn't it? Okay, distribute gets rid of parentheses. Are there any parentheses to deal with in there?
No.
None to worry about, okay? I like to use this reveal tool, so give me a second. What's the second rule say? Combine like terms on either side if possible. So let's just take a look at it. Here is the left side of the equation. Can you put 5n minus 7 together at all?
Yes.
No.
Not quite. You don't have like terms here, do you? All right.
Yes.
Well, what if I look at the right side of the equation? I'll look at the right side here. That's the right side. Can I put any of that stuff together? No. So even though we checked step 1 and step 2, did either one of those rules apply here? Okay. Check out step 3 then. That's where we're at in your notes. What's that ask you to do? Okay, this is the biggie. Get variables on both sides. What I'm going to choose to do here real quickly is this. On the left side, my variables, or I should say the variable expression is really 5n, isn't it? My variable expression on the right is 9n. Okay? We've got to get those to the same side. Now, I'm going to be very real about this. It does not matter which side your variable is on, as long as you can get a variable to one side. I've kind of programmed you guys to work everything from which side, though. Where do we usually have our variables at, left or the right? Left. So if I say I've got you programmed to put your variables on the left, this might be a good question to ask. Where wouldn't you want any variables then? If we want to get them to the left, where wouldn't you want any of those? On the right, right?
Yes.
Okay. How long was that up there?
It just
couple
happened.
minutes.
Lily's like,
Like 1 or 2 minutes.
all right, you're exactly right. I want variables on the left, so maybe make a note up here and put it like this. Maybe say try, whoops, wrong tool. Say maybe try to get variables
Trying to get variables.
on the left. Try to get variables on the left, all right? Let's zoom out so you can read that there. Try to get variables on the left. You guys have that statement down?
Yeah.
Okay. The 5n on the left, that's okay. Do I want the 9n on the right side of the equal sign? The answer is what? Okay, this is where things get very new for us today. Guys, listen to my questions. What kind of 9n do you have on the right side? Is it positive or is it negative? Positive. So just like all of our rules of inverses that we talked about, what would be an inverse to a plus 9n?
Negative 9n.
Subtract 9n. Now when I do this, I like to keep my terms lined up. Again, I'm going to draw this line, divide this out. I'm going to subtract 9n on the right. So if I do subtraction of 9n to the right side, what must I do to the left side? Okay. This is a part where organization is going to be very important. Am I subtracting a variable or am I subtracting a number? Variable. So it would make sense to line this up with the variable on the left side, right? Don't put it under the -7, but rather put the -9n under the 5n, because can't you combine these two terms right here now on the left side, as they both have a variable n in there? Okay. Watch what happens here. Let's work the left side first. We have 5n minus 7 minus 9n. Couldn't you combine 5n minus 9n right here? In that column, couldn't you combine those? What is 5n minus 9n? Negative 4n. So on the left side, this becomes the negative 4n. These two terms that I just combined right there became my negative 4n. What still is attached to the left side's expression? Minus what? Okay, that's going to equal on the right side. Quick question, what do you think is going to happen to the 9n's on the right side? They're going to cancel. Same idea, we're just canceling variables now instead of numbers. What's that going to equal on the right? 21. Oh my gosh. That third step took us to from a situation where I had variables on both sides now to where I have a variable just on one side there, okay? When we get to this point right here, this is starting to become like a habit for us in terms of what to do, right? Okay, what's my next step? Add 7. Whoops. I'll do that, what the heck. Okay, let me make some room. All right, what are the 7's going to do on the left? Negative 4n equals 14. Okay, so what are you going to divide by in the end? What are you going to divide by in the end? Got to get n alone, so what do I have to divide by? What's the coefficient of n? Yeah. Oh, you caught me. Good save. I was testing you, Lily. Thank you for catching my mistake. I appreciate it. Yeah, good save. All right. See, this is why I got to keep you guys around. Okay. Keep me in line.
job security, I think. We always have kids that
So
come
you
in.
mean you're gonna call
I plan on
security
staying
as
around.
Mr.
Okay,
Hayes?
Maddie. I need someone to pick on me every day,
Yeah,
so might as
yeah.
well.
Seriously, I mean, I plan on just going to Hawkeye and I'll
All right,
stay here
stop in
until-
every day. Yeah, my mistake. My mistake. Thank you very much, Lily. 21 plus 7 should have been 28. Gosh, dang. Whew. All right, so what do I want to do next then? I got ahead of myself. Divide by what value, Chelsea? Good. What am I going to get for a solution here, gang? These would cancel. What is 28 divided by negative 4? Negative 7. Rock on. Good job, guys. Guys, the whole idea is this. If you have variables on two sides, we really want to get into a situation where we move stuff around so that you have a variable just on one side. Okay? A little bit longer work-wise, isn't it? But aren't the processes pretty much the same as what we've looked at?
I don't get it.
Well, that's because you're wearing an Ohio State shirt.
Could someone give
Did you
me
guys hear
one?
about the University of North Carolina yesterday?
Nope.
In the news? Oh my gosh. Big cover-up for all their athletes and stuff and people doing tests. Check the news tonight when you get home. Okay. I think, okay.
But that's boring.
You think what?
Oh, I love watching the news.
I like
News
watching
24/7.
Today's Show,
Yeah?
and
No,
I may not be here November 17th because One Direction is debuting their new
Oh,
album.
that's cool.
So,
That's cool. Okay.
No.
Guys.
I'm gonna watch it on TV.
I'll go ahead and talk about what's going on here. Things are going to get kind of goofy here in a couple of these next problems. I want to show you what's going on. Were we able to get a solution for... John, are you okay?
Yeah, I'm good.
Okay. Were we able to get a solution? Were we able to get a solution for n in this problem?
See.
Okay.
Yes.
What I'm going to tell you is this. Sometimes there's situations that present themselves with equations where you have variables on two sides where you may get more than one solution or you may not get a solution.
And that's called no
Okay.
solution,
Right.
right?
This one here, what I'm going to do is I'm going to say this. I'm going to say that we were lucky here. We got one solution here, right? Not one direction, but one solution. Right? So we have an answer. Whoa, that's a funny looking hand. We have one solution here. All right? Maybe that'll be me at my meeting. One solution.
Oh.
Are you gonna sing math problems?
Yeah, I could sing math problems.
We're not.
You know what direction?
Maybe it'll be like a lullaby. Lull kids to sleep or something like that. Mathematical
Person
lullabies
sing.
to put kids to sleep. I think I'm onto something. Okay?
Okay,
All right.
Crossing.
I do want you to put a star by this next problem here, please. So go ahead and star this next problem because this is kind of goofy the way things work out.
Actually, that probably would put me to sleep.
Yeah. Hey.
All right, let's check out what happened here. I want to kind of get you a few. I don't know how I want to say this. Maybe just some things to look for, or shortcuts, or maybe some ideas about this. But guys, in this first problem up here, the two variables I circled, 5n and 9n, were they exactly the same variable? No, one was 5n's, the other one was 9n, so they were different, right? Okay. And what I'm saying about different is I'm saying, is the coefficient different? So 5 was different from 9, right? A little choked up about this stuff. Is it possible that you might have 6x on one side and 6x on another side?
Yeah.
Okay. I want you to be alerted to that. It's good.
Oh.
It's good when these have different coefficients, like the 5n and 9n. But it is possible, like we could have had 5n on the left and 5n on the right. And when you see that, I want you to alert yourself to that, all right? Kind of like the second example. Let's try and roll with this. First rule would say to distribute again, okay? So by your rule 1 that you're looking at on your paper, do we have to handle any distributions first?
Yeah.
Okay, help me do the left side. What's the left side going to distribute to be? 6x.
Plus 3.
Good. What's that going to equal on the right?
Equals 6x.
Okay, now watch what I do here, gang. I'm going to circle my variable on the left, variable on the right. I told you it's good when the coefficients of the variables are different. But what's alerting you right here now?
That it's gonna be the same.
Well, we don't know yet. I don't know yet, okay? But the thing I'm trying to alert you here to this is the following. 6x and 6x have the same coefficient is the word, so you want to write that down. This can be troublesome when you have variables on both sides with the same coefficient. All right, here's the situation. I'm going to cover up the right side. First of all, let me know, is everybody with me so far? You guys have that down? Okay. Get that down, let me know when you're ready to go, John. Good? Okay, kiddos, here's the deal. Take a look at the left side. Can I put anything together on the left side, like the 6x and the 3? Can I put those together? No. On the right side, there's just a 6x, so there's nothing to combine on the right side, is there? All right, here we go on this. This is where things get goofy. We need to get rid of this 6x on the right side because we said we don't like variables on the right side, right? Okay, so what kind of 6x is this? So what should I choose to do to get rid of that over here? Subtract 6x. So if I subtract 6x on the left, I better do what? I'm sorry, 6x on the right, I better do what to the left side as well? Okay, watch what happens here. On the left side right here, what do the 6x's actually do to each other on the left? They cancel, they're gone, right? Cancel to what value, really? 0. This really becomes 0 plus 3, so I could just leave 3 on the right side, doesn't it? Now, on the right side, if I cancel everything out, there's really no terms left over here. Okay, so if there's no terms left over there, what value could I put over on the right side to indicate that there's nothing there? 0. Oh my gosh. I want to scroll up to something here real quickly. In the first example, we said, you know what? Whoops, yep, right here. It's good to go ahead and go from this step to this step here because you go from an equation with variables on two sides to an equation with variables just on the one side. Okay? But we said there's some things to alert yourself to. And we said if you have the same coefficient for variables on both sides, something's going to happen. And if you notice right here, when we subtracted 6x, do we have any variables left now? They're just gone, aren't they? Okay. So here's what we say about something like this. If the variables disappear on both sides, we end up with a statement, a comparison of one number on the left to one number on the right. So here we have this comparison of 3, and we say, you know what, that's equal to 0. All right? How about the validity of that statement? Does that make any sense? Is 3 equal to 0? If 3 is equal to 0, a batter might as well not even come up, right? Because 0 strikes would mean 3 strikes, right? Does this make any sense? Okay, this would really be considered what kind of a statement, true or false? Okay, so here's what I want to point out. If you have a situation where the coefficients on the left and the right are the same, and all the variables drop out, you're going to have a statement that's either going to turn out true or turn out false. In our case right here, where the statement is false like this, we will simply say that there is, anybody want to guess? No solution to this. There is no number for x that would solve that problem. Can I show you something real quickly to get you to understand this?
Yes.
I think if I show you something graphically, I think this will make total sense. So give me a second on this. Let me know if you've got that down before I change the page. Everybody have that?
Yes.
Okay, I want to do something real quickly. What was your answer to the first problem we did? What did we get, -7? All right, I want to show you something real quickly, so watch this. You guys haven't been exposed to this type of stuff yet. You probably won't get it till next year, but I think that this is a really good visual for you to understand what's going on.
Where did we forget it?
Hang on one second, John. I'll come back, okay?
Will you show us again next year if I have you?
Oh, yeah. You'll be in here next year. Okay. What I'm going to do is this. I'm going to kind of put in a form of our first problem. What was on the left-hand side, guys? 5n plus what? 5n minus 7?
Yes.
What was the second side? What was the second side?
9n plus
So, plus how much?
21.
Okay, what I'm going to do is this. You guys, in that first problem that we did, what did we get as a solution? What did we get as a solution? N equals -7. Okay, kind of what I've done here is this. This is what a graph would look like for both the left side. Do you guys see the 5x minus 7, kind of like 5n minus 7 you have here? And the 9x plus 21? Okay, what's going on here is this. If you would put these what we consider function form, which we'll talk about next year, we're trying to look for the one point that's on how many of the lines? Well, both of them at the same time, right? Watch as I hover down below here. Watch as I hover down below here. Look at the first value when I hover down below on this point. What's that say? What's the first value right here? What was our solution to that problem? -7. So it looks like this one point where they cross, that first value gives us the answer to that equation, doesn't it?
Yes.
If I would set this part equal to that part, the red line's like the 5x minus 7, and the blue line's like the 9x plus 21. We're trying to find a value where they do what? Well, where the lines meet, right?
Yes.
Doesn't that kind of confirm our -7? Let me show you what's going on right here. Well, before I do that, I guess I should actually kind of sum this up by saying something like this. If I had to graph these, you would want to try and find a point where the lines do what?
Cross.
Cross. Okay. What was your answer in the second problem? There's no solution. Okay. Let me show you what that would look like graphically here quickly. Was it 6x plus 3 that we got to? Was that right? Okay. Well, originally, wasn't it 3 times 2x plus 1 like this? Is that what it was? Yes, no? Okay. And then in this one right here, let me kind of zoom back in now so we can see this better. Guys, when I put the two equations in like this right here, the 3x plus 2, 1 represents this red line, and the 6x represents the blue line. We kind of just said, you know, we're not really into this stuff yet, but we kind of get the idea that what's really going on here is looking for two lines and where they do what? Where they meet. What appears to be true about these two lines?
They don't meet at all.
They don't meet at all. They're parallel, right?
Yes.
Okay, what did we say about the solution for the second problem?
No solution.
There isn't one, which means these lines will never ever do what?
Cross.
Cross. Does that kind of make sense why there's no solution then there?
Yes.
Okay. Again, that's stuff that you won't cover this year. You won't see it till next year, but you know, that's kind of a visual of what's going on there. So keep that in mind. All right, questions on the first page at all? Anybody? Is it possible to get one solution? Yes. Is it possible to not get a solution? Okay, what's the alert? What am I alerting you to? Is it good to have same coefficients or not? Not good. It's good to have different coefficients on variables, right?
Yes.
Okay, let's head back to the notes here quickly. All right, second page, here we go. Let's try another one. Gosh darn it.
I thought you said that there were 3 problems on this one.
I'm sorry, what?
There were 3 problems on this one counting the back page, right? Just the example.
Yeah, yep. All right, guess what I'm going to have you do here?
Start it.
Star that example as well. All right. This problem is much like the last one we just did. Did we get a true statement or false statement in the last one? Okay. First things first, any parentheses, gang?
Yes.
Okay, what's the left side going to be, Taryn? Okay. Plus how much? 4 times 2?
Okay.
8. You guys agree that the left side is 4x plus 8? And the right side is already 4x plus 8. Okay, do I need to be alerted this time or not? Take a look at your variables and the coefficients of those variables. Same or different? Are the coefficients the same or different?
Same.
They're the same. That's a problem, right?
Yes.
Do I want this 4x on the right? No. So what should I choose to do to both sides? Subtract a. Okay. Help me out, gang. On the left side and on the right side. Oh my gosh, what's going to happen to the 4x's again? They're gone. What value is left on the right? I'm sorry, the left. I got to get my left and right fixed. Woo. I'm sorry. At least I'm good at it. Right? What are the 4x's going to do to the left? What are you left with on the left side then for a value? Everybody agree 8 on the left? What's going to happen on the right? 4x's are going to cancel here as well. What are you left with on the right side then?
8.
Okay, this is a situation much like problem number 2. It says, you know what? You've got the same coefficients to the variables. You do not have any variables left. However, right here, we have a statement where we're comparing two numbers. In the previous example, we said, you know what? 3 is equal to 0. Is that good or bad? What about this statement right here? 8 is equal to 8. This statement, 8 is equal to 8. What about that? Is that a true statement or false statement?
True.
That one's true. So, when all of our variables fall out like this, sometimes you're going to get a false statement, sometimes you get a true statement. Under the false statement condition, it said no solution. Anybody have an idea what a true statement might mean? Or a guess at least? There is a solution, and it turns out actually right here that there are many solutions. Squeeze it in here. Many solutions. All right.
Oh, I remember doing this in
I remember that. Now it's come back to me as well.
Yeah,
I remember doing that.
Okay, so let me go back to that graphing thing again. We got to a point where we said, you know what? We might have one solution, we might not have any solutions. Here I just told you what?
How many is a minimum?
Well, let me show you what many solutions mean. Many means infinite, okay? Well, let me just kind of pull this graph up here again quickly. The first equation up there was, well, I shouldn't say the first equation. The expression on the left was, what did it say? 4 parentheses, 2x plus what? X plus 2. And then the second one was 4x plus 8, wasn't it?
Yes. No.
All right, everybody listen up here. How many fields have I filled in for my graph right here? 1 and 2. But how many lines do you see up here? 1. It means that red line that you saw a second ago is the same as the what? Blue line. Quick question. How many of these points do they cross at? Is this a point where they cross? Is that a point they share? Is that a point they share? How long could I do this if that line extends infinitely in both directions? I do it for a long time. You guys want to do that?
No.
Oh, are you sure?
No.
Okay. All right.
That's an evil laugh.
Anytime. No, you haven't heard evil yet.
No, this is an evil.
If I get down to the situation again where the variables cancel on both sides and your statement turns out to be true, what are you going to say? Any solution. So just backing up here. Guys, in the first problem that we had different coefficients. How many solutions did we get here? 1. Okay. When I canceled all of the variables out and we got a statement that compared one number on the left to get a false statement, what did we say here? No solution. The last example we just looked at on the third page said, well, you've kind of got the same situation where the thing that's alerting me is I've got a 4x on the left and 4x on the right. They're going to cancel on both sides, but our statement this time was true. What did that imply? Many solutions, okay? So, here's what I'd like you to do here for about the next 5 minutes.
First of all, any questions so far? If you can get one solution, I want to know what the solution is. So don't just say there's one solution. If you get one solution, tell me what it is. Like x equals 7 or x equals 19. That makes sense? Okay. I want you guys to go ahead, take a couple minutes, maybe partner up with somebody on these 4 problems, try them on your own. When you get done with those 4 problems, check with a neighbor around you, see if you agree. If you disagree, talk about why you disagree. If you get stuck, ask a partner around you to help guide you through. All right, but take about 5 minutes, and then we'll pull some people up here to give these a shot, okay? So go ahead and roll with it, okay? Anybody need a calculator quick? Do you want? Question?
Yeah. I don't understand this. Like, it makes no sense to me.
Why?
Like, I know how to do it, it just doesn't make sense.
What are you going to move first here?
Well, you're gonna try to.
So I'm trying to come out. Do I want this variable on the right here? Let's do the first one again quickly. Maddie, you're going to talk me through this, okay? All right, top left. All right, Maddie, I'm just going to go right through the front part of the notes again. I've got it memorized. Are there any parentheses to work with? No. Look at the left side. Can I put the 3n and the 6 together? Can I put the 5n and the 20 together on the right? Okay, so I've got to get this 5n out of here. I don't want variables on the right side. Do you agree? What kind of 5n is that? So how are you going to get rid of that? If I do it to the right, I better do it to the okay. Maddie, I think that once you get this step down, the rest is just going to take over for you.
Yes.
Okay, what's the 3n minus 5n going to be on the left? What kind of 2, kiddo? 3 minus 5.
I did this all wrong.
Negative.
Negative
2.
2n.
Yeah.
And then still attached to that expression is?
This.
Okay. And what's that going to equal on the right?
20.
Okay. Are you good now?
Yeah.
Okay. You've got to get that variable moved, all right?
I did mine a little bit differently than you did. For the solution, you made 13. Yeah.
Yes. Yes.
I am?
Yeah.
I just worded mine a little bit differently.
Good to go.
Okay, thank you.
So how come for this one we have one solution, this one has one solution, and that one has many solutions?
Coefficient's the same or different? Different. Coefficient's the same or different? Same. So that's what we do. No solution or any solutions.
Like the math is one.
Because you got down to being 3 equals 0. That's the what? Equals 3 equals 0. That's the one where you have 2 parallel lines that won't cross. So if they don't cross, they don't share a common point. Right? That's why there's no solution.
The first thing I know a little bit
Is
about
that a
it.
true statement or does it equal the same number? Okay, so that's a true statement, right? So we get a true statement here. It means there's many solutions. Think about it. Let x equals 0, what's 0 plus 2? 2, right? 2 times 4 will be what? If I then put 0, we get a value later, right? You put 0 here, what's 4 times 0? 0 plus 8 and 1. Does that work? You put a 1, what's 1 plus 2? 3 times the 4. 12. You put 1 over here. 4 times 1 is 4 plus 8 more is 12. Okay, I've already put a 0 and a 1 here. I can keep on going with all these numbers. We're going to get the same value. Right here we get 4x equals 4x plus 8 equals 4x plus 8. Aren't they the same expression? So no matter what I put in over here, it'll be the same as if I put it in over here, right? I can put a lot of things on the right. Therefore, okay. All right. Anybody got this first one, by the way, solution-wise? Kim? Got an answer?
No, I actually.
All right.
I knew.
I do have an answer to the first one.
Yep. Yep. So -4, right? Okay, I'll give you about another minute here, and we'll come together as a group and talk about these.
said, tomorrow we've got some time to practice this and work on this and get better at it as a group. So if you're not 100% sure right now, don't panic too much. Okay, how many of you got at least 3 of the 4 accomplished right now? Yeah. Yep. Most of us are right. All right, let's talk about this so we can get through everything today, and I can at least send you out of here with a packet full of notes to refer to. Okay, so we got started on this one, Maddie. I'm gonna let you finish this one out. What's my next step then in solving that first one?
You're gonna add 6
Good. Good, good, good. All right, so on the left side, what have I got?
It's the left side, you cancel it out, so -2.
All right. And on the right side, what's my sum of 20 and 6?
26.
Excellent. All right, so what did you end up with after you did your division now? How many have negative 13 on the first one? Awesome. Excellent. Excellent job.
Yes.
Okay, so this is the idea. If I go back up here, the 3n and the 5n, were the coefficients the same on the variables or different? Different coefficients, good stuff. It means you're probably going to get an answer. And I shouldn't say probably, it means you're definitely going to get an answer, all right? So when I did this right here, my n value is negative 13. Whoops. Negative 13. Okay.
That's terrifying.
Well, it is almost Halloween, so these spooky problems are good, right, John?
Yes.
Okay. Well, volunteer to talk me through the second one. Want it, Allie? Okay, go ahead, Allie. Where are you starting?
I did 12x equals 12x minus 1. And then I switched it around the problem.
Okay, real carefully here. I agree with the 12x part on the right side, but instead of -1, make sure you distribute 4 also to that second value. Instead of -1, we should probably have minus. You gotta take the 4 times the 1 also. So -4 on here, right? Won't change anything that you had. Okay, so do exactly what you were doing. What did you do next?
I had -1.
Okay, do you understand why I have -4 up here? I've got to distribute the 4 to the 3x and the 4 to the -1 also. Okay? Now, before you tell me what you did, do I need to be alerted to anything in this problem? Why are you shaking your head? Yes. These are the same coefficient. Okay? So what did you do next now, Allie, in your problem?
I switched it around and made it.
Oh, you made it look like this, 12x minus 4?
Yeah, and then equals 12x.
Okay, that's fine. Yeah, if you like it that way, that's totally fine. We've talked about rewriting stuff. All right, how about after that step?
And then the one on the right, I minused it to the one on the left.
So you subtracted 12x from both sides, if I understand you correctly. Is that right? Okay, good. Let's see what I get. Looks like these will cancel here. Allie, when I cancel everything on the right, I have nothing over here anymore. So what value is going to indicate nothing? 0. Okay. So all the variables have dropped out. I can't even solve for x in this case. So we got to look at this comparison and say, is this comparison of the two values I have on the left and the right the same or different? You said false. This is a false statement. Implying what? Exactly. False meaning no solution to this problem. Very good, Allie. How many had no solution for that one? Okay. Okay. Let's try a couple more here. No solution to that. Good. How about a volunteer talking through the third one? Everybody have that one down here?
Oh, I got that one.
Everybody got it? You got the third one for me?
Yeah.
Okay, let me get it booted up here and make some room. All right, you want to talk me through it or you want someone different to do it?
No, I'll do it.
Okay, help me out.
So you're gonna distribute
Okay.
3 to the 2 end, and you're gonna get 6 end.
Right?
And then you're gonna add your plus, and you're gonna distribute the 3 to the 4, which you're gonna get 12.
All right, so that's the left side distribution. Turns out you also have to do it on the right side.
You have to distribute.
Same thing. Okay, go.
So you're gonna distribute your 32 to your 3 and get 6 in.
Okay.
And then your 2 to your 6 and get 12.
Anything that you're alerted to right now?
Huh?
Anything you're alerted to right now? What?
You're gonna do
Okay. Subtract 6n from both sides, right?
yeah.
And again, the alertness says, well, the coefficients of the variables are the same again. Gone here, gone here. What's your comparison again, Maddie? You just told me what equals what?
12
Okay, so since the variables have dropped out, we got to go ahead and talk about the validity of this statement. 12 is equal to 12, so this is a true statement implying that there would be what? Many solutions. Excellent job. All right, very good. How many had many solutions for that one? Excellent. Good, good, good. I'm feeling good about this.
Can you write true, or do you have to write true and?
If you just want to put MS down, I tell you what, the symbol for infinite number of solutions is a sideways 8, okay? It's an 8 that's still in bed, and I'm very jealous of that, all right? Yeah, it's a sideways 8. That just means many solutions, okay? Goes on forever. Yeah?
What if after we write it, like after like solve like 6 and 5, when we know that it's like many, can we just?
I was waiting for someone to say that. When you get up to this point, so are you saying, let me just back up a little bit here. Still backing up. Beep, 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 beep. Okay, what happened here? Now it's stopping. Are you saying right there when you get to this point? So, can I tell me what you're thinking here, Chelsea? You're saying, I know it's going to be 12 equals 12 because the 6 ends are just going to drop out. Yeah, if you can recognize right here that what you have on the left and what you have on the right are exactly the same thing, you're going to get a true statement doing the rest of the work. So yes, if you recognize that right away, Chelsea, go right ahead and write many solutions at that point. Okay, excellent observation. All right, everybody see what she's talking about here? I already know the left and the right are the same here, so she's saying, well, why don't I just write no solution now, or many solutions now? Or let's do what Fratsky wants us to do. Many solutions. How's that sound? Infinite number of solutions. Sound good? So if you just put this symbol down right here for many solutions, you're good. All right. I love it.
Yes, I do.
Okay, let's do the next problem. All right. Hey, I don't like this negative 2x over here, so how am I going to eliminate the negative 2x? I'm going to eliminate the negative 2x.
Yes.
I'm going to add 2x. We're going to run through these kind of quickly in the essence of time here. Adding 2x to both sides. Now be careful. I tried to trick you on this. I agree that 2x's will cancel on the right over here, won't they? On the left, are they going to cancel? They're both positive. Don't these add up to 4x on the left?
Yeah.
So my left should be 4x plus how much?
7 equals negative 15.
Yeah. When I talk about that same coefficient, I'm also talking about the same positive or negative, whatever it might be. Okay. So what's my next step here in solving?
Minus 7.
You guys are rolling today. I love it, love it, love it.
What's negative 13? I mean, what's 13 plus 7?
Negative 13. Well, 13 plus 7 would be 20. So that makes negative 20 on the right. Right, John?
Yeah.
Take a look at these left-handed writing skills. I've got math skills.
Maddie
Miller, I heard that.
Yeah, it was meant for you to hear.
Negative 20 divided by how much, gang?
4.
4. We are on a roll. What'd you get for a solution here?
Negative
What?
5.
I'm
X
supposed to
equals
do.
negative 5.
Excellent, you guys. I feel a lot better about this after going through those. Give me a show of hands. How many say, yeah, this really is pretty much the same thing. We just got that one step that we got to add to it, get the variable on the same side. Okay, we keep building, building, building. Very good. Let me know if you've got this down. When you've got this down, we'll take a look at the last 2 examples. I'll get you a short assignment due for Monday, and we'll get you out of here, okay?
There's no square on this.
I'll get you a square. You guys have this part down?
Yeah.
Okay, head off to the last page real quickly. All right, this problem right here on the last page this is where things get pretty interesting. We're going to have to start taking some things that we know to take for granted and apply what we know. So, what I would like you guys to do is this. Go ahead and draw a square real quickly. Now let's talk about what we're trying to do here. All right, there's my square. And I want you to label the square as I have them labeled.
Okay, yeah. Go on.
I'm going to call the distance on the bottom, or the length, if you will, 3x. And the width of this is going to be the expression x plus 6. Okay, so take a second and get that written down. All right, what are the directions above that problem asks us to do?
And the perimeter.
Find the perimeter. We need to know what the distance is all the way around this. Okay? Now, what's true about the lengths of sides in a square? What's true about the two lengths I have labeled here? Left side and the right side.
Alex.
Well, what's true of all four sides of the square?
They're equal.
They're the same, right? So couldn't I say that this side right here, 3x, is equal to what? X plus 6. They're equal sides, right? Because it's what kind of a shape? It's a square. So to start this right here, you're going to take your two expressions for length and width and set them equal to each other. So I want to set 3x equal to what?
X plus 6.
Okay. All right, no mystery here, but there's variables on both sides now, right? Okay, do you want this x right here? Do I want it on the right side?
No.
No. So if this is a positive x, how are you going to get rid of that?
Subtract it to the
Since there's no coefficient, we assume that's really how many x? 1. Good. So we'll subtract x to both sides. All right, watch what happens here, gang. On the left side, don't you get 2x?
Yep.
On my right side, what do you get? 6. All right, so we can easily solve for x, right? What is my x value? What is that number? 3. 6 divided by 2. 3, right? Okay, now if the directions in this had said, you know what, let's just solve for x and be done with it, would you be done? You bet you would. But what are we trying to find here? What am I looking for?
A perimeter.
Perimeter of the square. I got to know the distances. All right? Watch this right here. Guys, doesn't this length down here say it's 3 times x? So what could I plug in for x right over here? What did we solve for x? What is our x value right here? We got a 3, didn't we? Couldn't I plug 3 in there? Couldn't I also plug a 3 in here as well? Okay. Real quickly, do you guys agree that the length of this side is 3 plus 6 now?
Mr. Person, I need a band-aid direction.
Top right drawer. Johnny. Desk, top right drawer. You guys agree that this will be 3 plus 6? Because I plugged 3 in for x, right?
Top right-hand drawer.
What's this distance right here on the right then? What is 3 plus 6? 9, right? Same thing down here. Isn't this distance now 3 times my x value of 3? Well, coincidentally, what's 3 times 3 mean?
I'm not seeing them.
John,
Like
I'll get
right
one in a
here.
second. 9 as well, right? I just head down to the nurse quick, okay?
Okay.
All the sides are 9,
All my
right?
stuff.
Just come back and get it, okay? If all the sides are 9, how are you going to find the perimeter? You could take 9 times what? 4, or I could add up 9 4 times, couldn't I? So in this case right here, my perimeter would be each length of 9 times 4, which is what value again? 36. Okay. All right. We're not going to have time to finish this last one up, so we'll look at one again at the very beginning of tomorrow. What I want to do is get your assignment written down here quickly. We'll do the quick quiz tomorrow. You know, you guys did a great job with this today. Here's your assignment. It's on page 805. I'll write this down for you. You guys have any questions before I turn you loose today? Page 805, I'm asking you to do the following problems. I would like you to do problems 18 through 26. You're obviously going to have to show your work, so do I need to write that down? No. Okay, problems 18 through 26. Let's go do for Monday on this, okay? Do for Monday.
Are you the laser or just correcting?
I'm sorry.
Are we doing the two or are we just
I'll probably look at these, so you'll make sure you go on and do these, all right? Okay. Okay, so make sure you've got that down. Any questions at all? Okay, I'm going to be taking off at 12:30 today, so I won't be here this afternoon, but if you run into troubles, stop in anytime tomorrow. I'll be more than happy to help you out, okay?
Did you say another one else? What did you say about